Welcome to video 4.1 of Asteroids, where we're going to look at placing enemies in our game world. And so we left off with the player being able to attack. So they can fire a laser and fly around. But we have nothing to actually hit with that laser. And so now we're going to start creating an asteroid enemy. And this is going to be a multi-step process. We're going to need to create the asteroid prefab first, and that's what we're going to do in this video. And then from there, we need to start adding the code to spawn asteroids and to register damage and be destroyed, and have the big asteroid spawn little asteroids when it dies. So we've got a lot to do with it, and so let's get started. So again, I'm going to hide the player ship for now because I'm going to be working on my asteroid in this center space here. And so let's start similar to what we did with the laser. I want to have the logic and code from the asteroid separate from the graphics of the asteroid. So I'm going to start with an empty game object, and I'm going to rename it to AsteroidBig, and then press enter. So we're going to do the big asteroid first. I should at this point give it a tag. Because my asteroids will need to know that they are asteroids. And so let's go do that. Let's go to add tag. And we're going to add a new one called asteroid. And what's going to be convenient about this is, is that I would be able to tag my big asteroids and little asteroids all as asteroid. And so the code for collision, the code for weapons hitting stuff, it's all going to be very similar because it's just going to be checking for this asteroid tag. So let's go switch its tag to asteroid. So we have that there. Let's fix the transform, because again, as you can see, it inserted it into some very strange coordinates. So let's reset the transform. And at this point, we can then choose to place the model for the asteroid. So there's three different ones that are built into this assets project. We've got this one, which is, it's kind of lumpy, very cylindrical. Now we've got this one, which is a little less cylindrical, and we have this one, which is probably the roundest of all of them. So we can just pick whichever one we want to use. Something that you could possibly explore is randomly choosing a model. And that's not too terribly hard to do, especially if we're setting it up like this. Something to kind of give you some thoughts on how you could probably do that is you'd make the graphics a separate prefab, and you would have it randomly pick one of different prefabs inside of some code here to create the child model with. But let's just not overcomplicate this, and let's start with asteroid 1. That'll make a good one for our big asteroid. And so take this model and drag and drop it into the hierarchy. So once it's in the hierarchy, we're going to then be able to start adding stuff to it. So let's move this under AsteroidBig to make it a child. I don't need to really worry too much about the initial rotation of the asteroid, because it is going to rotate in the game, so I'm not going to really kind of modify too much about this. The only thing I have to be aware of is that if I'm going to choose to rotate the asteroid in game, the model is going to move with it. So whenever I set up the collider, I just need to make sure the collider and the model kind of match at this initial point. And then from there, I could worry about other things. So with the model here, there isn't a whole lot we need to change. I think all of these defaults are fine. We could always set this rotation back to 0. It really doesn't have much impact on how this is all going to play out. My asteroid just starts standing up, and that's fine. So let's go back to the parent object of big asteroid, and we're going to start adding the components that we need to get it to do what we need it to do. And really, since it's just a object that moves, it's just going to need to have a rigid body, and a collider. And then we'll put a script on it, and that's about all it needs. So let's go to components, physics, rigid body. In general, anything that's moving inside of a 3D game would want to have a rigid body. And so we attach it. And we're going to do very much the same thing that we've done in the past. We do not want to use gravity, and we do want to freeze the Y position. What's going to be an interesting thing is we're going to be moving more or less independent of the way that the model's rotating, which is going to be kind of a cool thing to see. So that's all we need with the rigid body. Then we're going to go to component, physics, capsule collider. The capsule collider is going to give us the hitbox for this asteroid. And so right now it looks more like a sphere, but that's just because the way that the default radius works and the default height works, it just doesn't look very good. So I'm going to increase the height to 1.6, and then I'm going to look at it and see maybe it needs to be a little bit bigger. Because I can see part of it, I don't know, it's pretty close. Let's go 1.7. No, 1.6. Keep in mind the hitbox does actually influence a couple different things. It influences your ability to hit the asteroid, but it also influences the asteroid's ability to hit you. So you do want it to be kind of true to the model. If you're bigger than the model, then that's not going to, like, players will think that they wouldn't have been hit by it, but then they get hit by it. Let's maybe play with the radius a little bit. I think it does need to be a little bit fatter because part of it, like you can see on the left edge of it, is sticking outside from the radius. So I go 0.6. And that's probably good enough. I mean, maybe I could have shrunk it, but no, 5.5 or 0.55. I'll go with that. All right, and so we've got our capsule collider. I am going to turn on is trigger just so that it behaves as a sensor zone. The reason I'm using that is I don't want it to... I'm going to handle the collisions myself mathematically with other asteroids rather than letting the Unity physics engine take true hold. I could experiment with letting the Unity physics engine take hold of it, but for now I'm anticipating treating this as a trigger. Okay, so we've got pretty much everything we need with this AsteroidBig set up and ready to go. So I do want to turn it into a prefab at this point so that I can be ready to make more of them. So let's make another folder inside the prefabs here called enemies, or just enemy. Oh, it didn't call player plural. So we have a folder called enemy. And so I'm going to take this object and drag and drop it into the enemy folder inside of the prefabs folder so that I'm ready to spawn new asteroids whenever I need to. But we still have a few more things we need to attach here. Let's get it so that it can get an initial rotation and spin around, and then we will, in the next video, deal with damaging it with the laser. So we need a script. And that will be here. And so we have a player folder. I mean, we could make one for enemies, and I guess we should. We'll create a new folder called enemy, and we will create our script there. And I will call this AsteroidBig, no spaces, because you cannot have spaces in a class name. So it creates the script. I'm going to double click it to get into Visual Studio. And so here is my asteroid. Not a lot going on yet. So I always like to start with my instance variables. And let's set up some rotation variables. And so I want to set up essentially what would be a rotation speed. I'm going to call it a tumble speed. So public float tumble min and public float tumble max. This is going to refer to how fast the asteroid spins around in the space. Call this movement variables. And so let's set up a move speed range. So we have public float move speed min. We'll set that to 1, and we'll do public float move speed max, and we can set that to 3. So these are values you can change to make the game whatever you want it to be. If you want the asteroids to be moving faster, if you feel like this is too slow, this is going to be the speed that it moves in the world with. So that's what these are going to control. It's going to be between 1 and 3, a velocity of 1 and 3 essentially, or the magnitude of the velocity. Speed will represent the actual value that we pick. And now I need to keep track of some components. So we need a rigid body for the rotation and the movement. And we need a vector 3. Well, I guess that's not really a component. That's going to be a move thing. And we're going to call this move direction. And this is the basically the randomly generated direction of motion. So we're going to randomly generate a speed, and then we're going to randomly generate a move direction. Now, speed is probably a little superfluous because velocity is going to magnitude of the velocity kind of covers that, but you know, something we'll deal with later. And now the gameplay variables, I'll put this here just to remind myself that that's going to need to happen, but that's going to be done in a later video. We're going to come back and do that once we get these asteroids floating around and spinning around. Then we're going to finish designing the rest of this class. So we do a lot of what we've been doing before. If I want this thing to move, which includes rotations, now I could handle rotation using the transform, but it works a little bit cleaner if you let the rigid body do most of this. So my rotations, my movement, I'm going to let be a rigid body thing. So we need to attach that. Body equals get component, rigid body. Let's see, other things that we might need to do. Well, we don't have to worry about, I'll put a note here to do gameplay stuff, because I know eventually I'm going to have to come back to doing those. Let's generate our rotation speed. And so that's what we're going to start with. Float tumble speed. This is just a local variable because once I set this in motion, I'm not going to need to play with it at all. So float tumble speed is going to be set equal to random.range. This is our actually first usage of random in Unity. And it's actually pretty easy and intuitive to use. And you can even read the tooltip here. It is different from both C# and Java. I don't know why they chose to do this, but you can see that the min and the max are inclusive. Whereas in Java, and I think in C# as well, this max endpoint tends to be exclusive, meaning it doesn't include the value on that second input. But in Unity, it does. So that's something you should just kind of make a mental note of. So we're going to generate a number between the min and the tumble max. And that's going to be set to tumble speed. And now we're going to apply the, apply rotation to the rigid body. So we're going to apply the rotation. So body.angular velocity. So this is kind of defining the rotation vector. And we're going to do random. And this is a random that you haven't seen before. And it'll be interesting. We're going to do random.onUnitSphere times tumble speed to give it the magnitude. So you know the unit circle from pre-calculus. The unit circle is a radius 1 circle with different angles on it. So if I'm generating a random unit sphere, we're generating a random length 1 vector that's anywhere on a three-dimensional sphere. So it's basically guaranteeing you that you're going to have a magnitude 1 three-dimensional point. And so we multiply this magnitude 1 vector by the tumble speed to give it its magnitude of its speed. So maybe like it could pick something that's purely an x rotation, purely a y rotation, purely a z rotation, or some combination of the three, but so that it is a total magnitude of 1. So now we're going to set up the asteroid move speed. And so that's just going to be another random generator. So we'll do random.range move speed min to move speed max. And then again, much like we did with the random rotation, I want to generate a random direction for this asteroid to move in. So I'm going to say move equals, oh, what was that? Move direction equals random on unit sphere. I don't want to pick, there's another one that's like within, like inside unit sphere. And I don't want to pick that one because it could pick 0, meaning the asteroid wouldn't move at all. And so this is guaranteed to be a magnitude 1 movement, and I'm effectively just going to multiply it by the speed to take this, XYZ movement and multiply by speed. But we only want to move in 2 directions. We want to move in the x or the z direction. However, the unit circle generates x and y, which isn't very useful. So I think it's easier for us to generate the 3-dimensional direction. And then going back to the code, we're going to flatten the y movement. And then we're going to renormalize the vector. So if you're familiar with normalization of vectors, it's just the idea of you take any x, y, z, or whatever components, and you turn it into a magnitude 1 vector. Because by flattening the y, this vector may no longer be magnitude 1 because it's lost one of its dimensions. And so by normalizing it, we can account for the fact that we've flattened the y. So like mathematically, to think about normalization, pull up Notepad and do a quick example here. So if this random move direction generated the vector 0.3, 0.3, 0.3, I'm actually representing the percentage of the unit vector. This is not 100% mathematically correct, but this will give you a general idea of what's happening here. That if you're moving in those amount of directions x, y, and z, that essentially equals 1. But what I just did was I went through and flattened the y to become 0. So at this point, this is no longer a magnitude 1 concept. Not that these worked out to be 1, but you can kind of clearly see that this isn't going to be the same amount of power behind it. And so what it's effectively doing, and again, this is really sloppy math, is it's going to normalize the vector to represent like this. It's going to kind of proportionalize back to being a scale of 1. So instead of this not being adding up to 1, it now will add up to 1. Now I know that the magnitude of a vector is defined essentially by the Pythagorean theorem, and so you'd be doing a 3-dimensional Pythagorean theorem, and it's normalizing it so that that 3-dimensional Pythagorean theorem works out to be a value of 1. But the math behind that is a little more complex than I want to show in just a quick notepad. But this is the general idea of what's happening. The numbers would be different, but the concept is the same. That we had our original vector that was randomly generated. We flattened y, And so to account for that, to bring it back up to a length of 1, we have to proportionally rescale those. And so that's what this process of normalization is doing. And that way, because once the magnitude's 1, when I multiply it by speed, I can guarantee that it's going to be between these ranges. If the magnitude was less than 1, when I multiply by speed, it would be possible for the total velocity of the asteroid to be less than 1. And I know that is a lot of mathematical explanation, but that's why a physics background is extremely helpful in game design, to understand why certain commands like this matter in a gameplay context. All right, so let's just move the asteroid and then test it, and we'll call it good. We are going to come back to the update. You know, there's going to be some gameplay stuff here. And we're going to jump over to our favorite movement method, fixed update. All right, so in fixed update, we don't have a whole lot of tasks, and we're actually going to see movement in another style. And we're doing this as a translate. So we take our move direction, we multiply it by speed, and then we multiply it by time.delta time to make sure that it smooths out to be normal with the frame rate. And we tell it to make this move relative to the world space, not relative to the asteroid, because the asteroid's going to be spinning. And if the asteroid is spinning and we move relative to the spin of the asteroid, it's going to start trying to like move up, or just that movement vector changes as it spins. So instead, we're telling to apply the movement to the world space. That's the difference between this. So you see we have our vector here, our gizmo. That's X, Y, and Z and all that stuff. But if the asteroid were to spin, which it's going to do, and then we look at that, now we look to see, it's going to start moving it up off of that plane, because we did flatten the Y, and so it's only moving in the X and the Z, so it's going to try to like fly up into the sky in that case. So, but if we switch it to using world space, it's only going to move in the X and the Z relative to the world, no matter how much we rotate this asteroid. It's always going to still be moving relative to the world space. And so that's actually what that command is doing there. Let me clean out the rotation on this. Reset rotation. Yes. Okay. By telling it space.world as opposed to, I think, self, that would move relative to its own X, Y, and Z. And then we need to do our screen wrapping. And so that's just boundary dots check boundary. And we pass it in our game object, which is this whole entire thing. And so it will screen wrap for us. See that static method that we made prevented us from having to rewrite that edge detection code here. We can just condense it into one line. All right, and so this should wrap up our first pass at the big asteroid code. We will need to return to put in the gameplay stuff, but this should cover all of the variables and stuff that we would need to do here. All right, so I'm going to save this, and I'm going to head back and test it after I've saved it. So I need to, well, Unity is compiling the script. I need to attach this AsteroidBig script to the parent object here of AsteroidBig. So I'm going to just drag and drop it right there. And you can see that it loaded all those initial values. Let's update the prefab while we're here. So we're going to go to Apply All. And let's see what happens. So let's re-show the player. Maybe I'll move this asteroid a little bit off to the side. And let's hit play. And we can see that the asteroid is spinning. And you can even see our lighting effects interacting with the asteroid now. So as I fly by it, the blue from my engine lights it up, the lasers light it up. So it's getting lit by the things in the world. It flew off the edge, and it is reappearing over here on the edge. So it is actually truly screen wrapping. And it is slowly floating there. Now, again, that's a decision for you. If you feel like that's too slow, you can always change that. Although I do want to point out the fact that I do feel like it's kind of small. So let's up the size of this asteroid a little bit. Maybe go like 1.3 on all the dimensions of the scale. And so it's 1.3 across the board, meaning it's going to be much bigger. And that also proportionally scales the capsule collider as well. So it is going to scale everything up inside of that asteroid. So I think that that's a better scale for here. If we're calling this big asteroid, I'm good with that size. So I'm going to reset the position only, but not the scale. And then I'm going to update the prefab one more time. And so I'm pretty happy with how this big asteroid came out. I would be safe to delete it because I would be able to put new big asteroids into my world whenever I want. You'll notice that if I drag and drop it into the hierarchy, it actually sets it to a Y value of 0. But if I drag and drop it into the game space, it may set the Y value to something weird. So I actually prefer to drag and drop into the hierarchy. And so you can see each one of these asteroids is going in a different direction. And so we've got random movement on the asteroids. And so that is where we will stop this here. In the next video, we're going to look at getting the asteroids to acknowledge being hit by a laser. And if time in that video, we can do the particle effects. And then from there, we've still got to make the small asteroids appear, and then we've also got to make them hit the player. So we've still got a lot more to do with these enemies. But thank you for watching, and excited to see the next video.